Hi, I'm Tyler Jordan. I am the founder of the Earth Society, a free online network for the development and dissemination of philosophical, psychological, and economic ideas. I am also the developer of Anonymous, a free and easy-to-use new Linux operating system for secure web browsing and Bitcoin exchange utilizing the Tor and I2P networks. Also, Anonibox, a plug-and-play Wi-Fi router that sends all your internet traffic through the Tor network, no matter what computer or operating system you choose to use. To support my work and the Earth Society, please consider purchasing my products or making a donation. To interactively discuss our video productions, please visit the Earth Society forums. Comments left on YouTube are unlikely to be read. Our website is earthsociety.org. And thanks for listening. The problem of induction, the utility of science, and the wisdom of Socrates. In this video, I will be discussing the scientific method, empiricism, and inductive and deductive reasoning. This is my first video, and many topics that I intend to present in the future will reference back to this one. I believe that a thorough understanding of the problem of induction is really vital in this day and age, as the misuse and abuse of inductive reasoning by scientists and politicians alike is not only rampant, but incredibly harmful to a civil society. Part of this presentation is taken from an article by Stephen Law entitled The Problem of Induction, Explained Simply, which itself is from his book, The Philosophy Gem. Philosophy, to a large extent, concerns definitions and the rational analysis of language. As none of us speaks a perfectly identical language, each person having their own subset of language, it's important to come to a mutual understanding of the key definitions, as these key terms are important and often critical for effective transmission of the concept as a whole. The key terms for this presentation are science, the scientific method, empiricism, induction, and deduction. So I will now give my definitions for these terms. The scientific method, as devised by philosopher Karl Popper, may be broken down into two general parts, the first being to observe nature and to devise a hypothesis explaining potential relationships in nature. The second part is to devise an experiment that would prove this hypothesis wrong. This is called falsification. Core to falsification is attempting to find a contradiction between the stated hypotheses and reality. If such a contradiction is found, then the hypothesis is discarded and the method repeats itself. Importantly, the scientific method is meant to determine if a hypothesis is false, and only false. It says nothing of the truth of a hypothesis or theory. This methodology gives a logically deductive conclusion of falsehood. Science is the act of following the scientific method, not any individual part of the scientific method, but the method as a whole. If one only performs a part, then they are not doing science. So, for example, within science, the process of gleaning data from the world is empirical analysis. This is a critical part of the scientific method, but by itself, it's not doing science. We all use empirical analysis every day, from birth to death, yet we don't say that everyone is a scientist. This is important, as there are many people calling themselves scientists today who are really empiricists or engineers, but who are not following the scientific method. It is important to challenge the work of these people by asking if they are utilizing the scientific method in an attempt to falsify their hypotheses. Any good argument consists of one or more claims or premises, and a conclusion, arranged in such a way that the premises are supposed to support the conclusion. Arguments come in one of two forms, deductive and inductive. An example of a deductive argument is as follows. All cats are mammals. My pet is a cat. Therefore, my pet is a mammal. Two things are required for a good deductive argument. First of all, the premises must be true. Secondly, the argument must be valid. The expression valid in this context means that the premises must logically entail the conclusion. In other words, to assert the premises but deny the conclusion would be to involve oneself in a logical contradiction. A person who claims that all cats are mammals and that their pet is a cat, but who also denies their pet is a mammal, has contradicted him or herself. Inductive arguments are quite different. Suppose you observe 1,000 swans and discover them all to be white. You don't find a single non-white swan. This may give you a feeling that you should conclude that all swans are white. However, you would be incorrect to say that such is true universally. Inductive arguments differ from deductive arguments in that their premises are supposed to support, but not logically entail, their conclusions. The argument for all swans being white is not, nor is it intended to be, deductively valid. To assert that the first 1,000 swans one has examined are white, but that not all are white, is not to contradict oneself. And in fact, not all swans are white. Black swans exist in Australia and New Zealand. Nevertheless, we suppose that if all the swans we have observed so far are white, then that makes it more likely somehow that all swans are white. The premises support the conclusion. We believe that an inductive argument can justify belief in its conclusion, despite the fact that we have not provided a logical guarantee that if the premises are true, then the conclusion will be. We rely on inductive reasoning in arriving at beliefs about what we have not observed, including our beliefs about what will happen in the future. Take, for example, my belief that the next time I sit in a chair it will support my weight. How is this belief justified? Well, I have sat in a great many chairs and they have always supported my weight before. That leads me to think it likely that the next chair I sit in will support my weight as well. But notice that the statement that all the chairs I have ever sat in have supported my weight does not logically entail that the next chair will. There is no contradiction in supposing that, even though I have never before experienced a chair collapsing beneath me, I could still imagine that it's about to happen. Given there is no logical reason to conclude that the chair will support me or won't support me, it then follows that I can't justify my belief that the next chair will not collapse. So if my belief is justified at all, it must be by means of an inductive argument. Whenever we reason inductively, we make an assumption about the uniformity of nature. We assume that the universe is patterned throughout in just the same way. Imagine an ant sitting in the middle of a bedspread. The ant can see that its bit of the bedspread is paisley patterned. So the ant assumes the rest of the bedspread, the bits it can't see, are also paisley patterned. But why assume this? The bedspread could just as easily be a patchwork quilt. The bedspread could be paisley here, but plaid over there. Or perhaps, just over the ant's horizon, the print on the bedspread turns into a chaotic mess, with blobs, lines, and spots muddled up quite randomly. We are in a similar position to the ant. The universe could also be a huge patchwork with local regularities, such as the ones we have observed, the sun rising every day, trees growing leaves in the spring, objects falling when released, and so on, but no overall regularity. Or perhaps the universe becomes a chaotic mess just over the horizon, with events happening entirely randomly. What reason have we to suppose this isn't the case? This is the core argument of David Hume, a renowned philosopher of the 18th century. It seems that, if it can be confirmed at all, the assumption that nature is uniform can only be confirmed by observing that nature is uniform locally, and then concluding that this is what nature must be like overall. but such a justification would itself be inductive. We would be using precisely the form of reasoning we are trying to justify. This is a clear case of flawed circular logic, with which it is impossible to determine truth. Perhaps you're not convinced. You might suggest that there is one very obvious difference between, say, trusting induction and trusting your local fortune teller. For induction actually works, doesn't it? It has produced countless true conclusions in the past. It has allowed us to successfully build supercomputers, nuclear power stations, and even to put a man on the moon. Your local fortune teller, on the other hand, may well have a very poor track record of making predictions. Hence, we are justified in believing that induction is a reliable mechanism for producing valid theories about the universe, whereas trusting the fortune teller is not. The problem, of course, is that this argument is yet another example of inductive reasoning. We are arguing, in effect, that induction has worked until now, therefore induction will continue to work. However, since the reliability of induction is what is in question here, it seems that this justification is, again, relying falsely on circular logic. It is, after all, just like trying to justify trust in the claims of the fortune teller by pointing out that the fortune teller claims to be reliable. As counterintuitive as it may seem, the belief that the sun will rise tomorrow is as unjustified as the belief that a 1,000,000-mile-wide bowl of tulips will appear over the horizon instead. Many would suppose the second belief to be insane, but as a matter of fact, the first belief is actually no more rational. In science, we rely on both deductive falsification to eliminate incorrect hypotheses about our world and induction to make predictions about the past and the future. A hypothesis that is not falsified may be considered a valid theory, which itself is true relative to the data used in attempt to falsify it. As any data set is finite, and as the observable universe contains an indeterminate amount of observable information, we can deductively conclude that induction cannot give truth. Many people today, scientists included, believe that humanity knows enough about our world to make probabilistic estimates regarding whether or not something is going to be true in the future. If you put someone on the spot and ask them, as a percentage, how much of the universe do you know, and how much do you not know? They will most likely be stymied. They cannot tell you honestly how much. They just have a gut feeling about it that stems from various sources and experiences. However, without knowing how much one doesn't know, one cannot make any probabilistic determination of truth. So it would seem that induction can only ever be taken pragmatically as a very localized relative truth, relative to the particular data set used at a particular given time and a particular place with both known and unknown sets of particular circumstances. Socrates said, "I know nothing except the fact of my ignorance." I believe that the wise individual must realize the fact of their incomplete knowledge of the natural world, and through this realization, one can then recognize the absurdity of inductive prediction. Thanks for listening. Please join in the conversation at theearthsociety.org forums. Thanks.